There we go. Don't worry, guys, at home, your faces aren't going to be showing. So we're talking about organizing data. The first thing we got to talk about is frequency distribution. Ooh. Distribution. Wow. I need hooked on phonics. Okay. It lists each category of data and the number of occurrences. Of each category. So let's do this. Let's start saying out loud your ages. Zoomers, I'll come back to you guys. You want to start? And we'll just go back and forth. Go for it. Next. 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 17. Next. 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 Flash is a weird age. Next. Okay is a weird age too. Next. 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 That's it. All right. Zoomers. Unmute yourself and speak.
17.
Next.
20.
Next.
18.
18 and 18. Anybody else?
21.
21 and 20. Okay, next. I'm gonna guess we're all done. Here, I'll make the older people feel better. All right. You guys feel better now? So you guys need to respect what I say, because for some of you guys, I'm like 3 times your age. And some of you guys I'm not, but so when we do a frequency distribution, now the ages went from 16 to 48. So clearly in this case, I would be an outlier. Okay, so you guys will learn about outliers later on, but outlier would be a data point that is like way off, which should make sense in this class, right? So what we can do is, in the frequency distribution, a couple of things could happen, right? We could write one looking like this. We can list all the ages. Actually, you know what? I'm going to take the 48 out because it's going to throw everything way off. So let's say I could list them as like 16, 17, 18, 19, and so on, right? I could do it that way. But what that would do is that obviously there's more. Another way of doing it is if we go, okay, instead of doing that, let's do it in groups, right? We can say, okay, I'm going to go 16 to 18. Then the next one will be 19 to, what do you think the next number should be? Is it 21? Or is it 22? So whenever we do this, the range of it has to be exactly the same. So if I have 16, 17, 18, that's 3 ages, right? So it'll be 19, 20, 21. Then I start with 22 and it goes to 24. Is it 24? 23, 24, 20, 22, 23, 24, and then 25 to, and then 28 to. Okay, let me rewrite these a little neater, okay? Because those are not neat. So you guys can write it down as well. 16 to 18, 19 to 21. Is that right? So here's a frequency. So here's the way I would do it. So again, remember that these spans have to be exactly the same. All right. So the way I would typically do it is I would use tally marks, right? So I'll go through the data instead of going, okay, I start with 17, so I'm going to count the number of 17s there are. I'm going to count the number of 16s there are, and so on and so forth. So what I would do is say, okay, I got 17 here. I'm going to put a dash there. 16 here, put a dash there. 17 here, 18, 20, 17, 20, 19, 20, 21, 19, 17, 19, 22, 19, 17, 28, 27, 19, 16, 29, 22, 17, 17, 20, 18, 18, 21, and 22, 20, right? Now I can write down what each one is. Except I wrote them really, really big. So that will be a frequency distribution. Is everybody okay with that? Pretty easy? Okay. So let's talk about relative frequency. That is the proportion of observations within a category. So the way there is a formula, but this should be pretty obvious to you guys. Relative frequency is equal to the frequency divided by I'll write it this way, but I don't know why it even says this. Because here's the thing about sum of all frequencies. Isn't it the number of observations that we just took? Right? Because one of the things that we might want to do when we're doing these tally marks, guys, right? We might want to add these numbers together and say, okay, 12 plus 12 is what? 24? 26, 28, 29, is that right? About 29. So what I would want to do is from there, I might want to count out the number of numbers I have written up there, right? To make sure that I have definitely taken care of all of them. Because knowing some of you guys will be doing your homework, you'll be doing tally marks, and then you'll see a squirrel run by, and then you're like, did I mark that one or did I not mark that one? Right? So always double check. So you want to make sure that there is actually 29 in here. Let me see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 29. Perfect. I do. Okay. So I would almost call this the sum of all frequencies as number of observations. Now, don't get me wrong. If they only gave you a frequency table, then yeah, sum of all observation would still mean that's the sum of all the frequencies, right? So in this case, guys, this is where things kind of get wacky because now I got to do it separately, individually. Meaning I have to come up here and I gotta say, okay, so this RF, right, is the 12 divided by the 29. Someone do the math. Give me a decimal place. .41. Excellent. Which would mean that like 41%. And I would even do this. Right? Does that make sense? I would even do that just so that I kind of have a reference to that. Don't worry, guys. I'll do this one for you. I got it. What is that going to give me? Huh? 0.7? Oh, I should have known that. Why should I have known that? It's like 0.5 something, right? But it rounds up to 6. Yeah. I should have known that. Why? Guys, look at this. Check this out. See this 12 right here? See this 2 right here? When I take the 12 divided by 6 to get the 2, is that right? So if I take the 0.41, 42, let's say, divided by 6, wouldn't it be 7? That's why I said it was, right? Dang it. Should have known that. Is it 0.4? No, 3. It was 3.4, isn't it? Is it 3.4? So I should just leave it at 0.3. There we go. Now, add those frequencies up for me. 0.41 plus 0.41 plus 0.7 plus 0.3 plus 0.7. Ooh. This might not work out. Huh? What is it supposed to add up to? It should add up to 1. And it's because we didn't go enough digits, that's why. Right? So if we go back up, let's go back to the 0.41. What was that? Give me another digit on that. So the 12 divided by 29 is 0.13. So this is 3. And then 0.07 was 0.068, I believe someone said. So that means this would be 3.4, and this would be 6.8. All right, now add those together. Should that give me 1? Or it's going to be 0.999. Watch. It's going to be 0.999. Okay. So I want you guys to realize something. So again, this is supposed to come up to 1, right? And we're getting closer and closer to 1 because of the number of digits we go out to. Everybody knows this? And this is the reason why we can't stop at 2 decimal places. We can't even stop at 3 decimal places. We gotta go to 4 decimal places. So let's go with 4 decimal places. So 0.4137, 6.8, so that's 3.45. No, 3.44. No, 3.45, isn't it? Is that right? Is it 3.44? Even with the rounding? Huh? Huh? Okay. And then 9 here. Let's check that out. Subsay. Subbot. Oh boy. So we should have kept on going, right? And here's the thing. That's pretty darn good right there. So when we talk about the relative frequency, let's put over here, go to 4. Yeah, because usually 4 is pretty significant. Typically 3 is pretty significant, but let's do 4. So I do want you guys to realize something, right? So each of these 16 through 18, 19 through 21, 22 to 24, 25 to 27, 28 to 30, each of those is a category, right? And within the category, the span or the range of it is exactly the same, or what is it called? The class width is exact same, right? Which was 3 numbers, exactly the same, okay? Any questions on that? Nothing. Nothing at all. The relative frequency? And this is the reason why in most math classes, when on day 1, I usually say, but now I wait until these questions come up because it's exactly it. So what I started to notice is that students will come up to me, say, I have a question, they'll ask the question, they'll answer themselves, and then they'll walk away. I answered nothing. So clearly it must be my face that answers these questions somehow. So I've always suggested to my students, so since in this class you guys need to get a calculator, that you guys would just kind of on the back of your calculator, find a picture of me and just stick it right back there. So that at night when you're stuck on a problem, you can just open up your calculator back and just let it sit there and then ask me questions and you'll answer it yourself. Maybe that's another moneymaker, right? Cardboard cutouts of Chan.
That's what I've been doing.
And then pictures of Chan that fit in the TI 8084 thing. Just don't let your significant other or your parents see my picture because they might think that you might need some meds, all right? So, but thank you. That's perfect. See, apparently I have an associate here that is asking these questions to throw me into that tangent. Perfect. So anyways, so for these, you could be also asked to do a bar graph. Better yet, should I even call them, in this case, a frequency chart? Mm-mm. Wow, that 30 looks awesome. Now, you could be asked to do a bar graph for the frequency, but you could also be asked to do a bar graph for the relative frequency. Okay. I'm going to cheat here. Where you guys can't do this? I don't understand. Can you just circle on your paper too? Huh? That is true. I'm trying to see if I can do it side by side, so it looks more gooder. This is 16. I could. How do I want to do this? No, that won't get me there. Want that 0.4. Wow. 2. 0.1. Yeah, I better do that. That'll get me into negatives. I can't do that. That won't work either. You know what? Let me just do it this way. Oh 06, 04. So this here is my frequency. And this is my relative. Relative frequency. Are we okay there? There is one more chart. Is that Pareto? Where you reorder Does that make sense? So essentially what I would have to do is I would take these two graphs. Oh, shoot, I'm gonna have to reword this anyways. So what I have to do is essentially take these and go in decreasing order. So lucky for me. And voila. The chart just gets shifted, so it's decreasing. Yep, from greatest to least. That's all it is. No. Not at all. Because they can use this to kind of show, right, what that class kind of looks like, right? So it's easier to find out. I mean, for me, I still think that this sticks out just as much as this would, right? It's just more in order of what's higher, what's lower. That was about it. I don't recommend either. Only because it's not like I read a whole lot of charts lately, right? So it's not like one is like, whoa. Now, I would say this, as a human being, as a consumer, when you guys do look at charts, make sure that you pay attention to details, right? Because a lot of times what they will try to do is that they will give you information that's skewed or graph that's skewed that throws you off and you don't realize it. Okay, kind of like, so in the morning my parents always watch Chinese news. They're Chinese, makes sense. And they're like, how is this possible that every single day there is 20,000 people in Taiwan that is getting COVID? You can only go 20,000 new cases every single day before the whole island of Taiwan is going to be all with COVID. I'm like, here's the part that they don't tell you though. They don't tell you that if these 20,000 are new or the 20,000 just got tested positive, because in China and Taiwan and Hong Kong, essentially you breathe, you're taking a test. I think they take a test every single day. So the people who just got tested positive, who are actually sick, well, guess what they're going to test the next day? Positive, right? Now, in America, you can take 10 tests in a row and you might have 5 positive and 5 negatives. I'm not sure what test they're doing in Taiwan, but apparently, and here's the thing, there's no marker up there that is like a ticker, right? That was like positive thing, positive thing, positive thing, right? And it's just like, is it really 20,000 or is it like 10,000 and you're just trying to scare the Chinese people to say, be careful, you got to get the vaccine, you got to do this, you know? So we have no idea when it comes to that. But to answer your question, I would say whatever they ask for, is what you should do. Okay. So it's not like a necessary recommendation because the direction is out of my hands. Well, it's not really out of my hands, but I recommend whatever it says. All right. So the next is called a side by side. Now, the side by side bar graph, however, is something you've seen before. Okay. So, so let me go ahead and give you a problem here. So you guys typically see these type of charts quite a bit. A lot of times with side by side, which makes sense because that will be comparing two things. So I'm going to rewrite this top part while you guys are copying the rest here. Don't like my writing sometimes. You guys seen these graphs before, right? Now, of course, you guys can do this with, so this would be also called a frequency chart, right? And this could also be, you can make this a relative frequency chart. Now it tells you what percentage of each one it would be. Okay. I won't finish this, but I'm just gonna let you guys see this because I think it's important for you guys to see it. So this way you guys can see that this is how do I want to do that? Let's do this. It's always interesting to see how I want to do. Come on. There we go. So that this way you guys can see what's 1999 and what will be 2017 as we go. And of course, you can see these as horizontal. So why do you think that people would rather see a horizontal bar graph than a regular bar graph? Do you think it's easier to read? So if we took, for example, this right here, right? So let me go ahead and shrink this. Let me take this. Hey. Except it's not going to be this way, right? So really what usually happens with this is that this right here will be down here. Actually, let me do it this way. Just screw that one up. Because now what is typically written really long, right? And if I was to write this as like one thing, so essentially when I'm reading this sideways, the important information sideways. Does that make sense? Where here, I wouldn't have to read it sideways. Right? So you think the one on the left? Well, I think we're more used to, because there are some, but there's not a whole lot of horizontal bar graphs that you would see out there versus a side to side. So I should probably put this as, well, which is, they're both side by side. But I do think that the horizontal one is easier to read just because the categories are easier to read, easier to type up, easier to write. Now let's talk about pie charts. So if I was to say, well, let's even talk about pie charts with this, right? So how would I decide to use this information and create a pie chart out of, let's say, 2017? So I'm only looking at 2017, and I want to put 2, 4, 6 different pies in here, right, into a pie chart. So a pie chart looks like a pie, right? So how would I know where to put these lines? Well, I mean, but how big of a piece of pie should each thing have? Because if we look at 2017, all these numbers are different, right? We're at 26,000, 60,000. I can't just divide the pie up into 6 pieces and call it a day, right? So how do I present $26,000 students in a pie versus a 60,000 students versus a 45,000 students versus 18,000 students? Huh? A percentage which is back to the relative frequency, isn't it? Which is back to the relative frequency. So, okay, so how do I divide this pie up into a percentage? Clearly that is 25%, that's great, but how does that help me? Right? How does that help me? But a scale, you're right, it is a scale of what though? How do I know what angle to put these on? So if I took this, right, and I did this, I know it's 50% on each side, right? If I do this, I know it's a quarter of it versus 3/4 of it, right? So how do I go about doing it so that I know where to put that this would be right versus maybe it's supposed to be this versus that? Excellent. So what she's trying to say is if I go from here all the way around, right, that would be 360 degrees. So we take that and multiply by the relative frequency. Then we should know the angle of those two lines. Does that make sense? Okay. So if you took this and said, okay, this is a quarter. So if I took 360 and multiply by 0.25, I would get 90 degrees, which is exactly what that would be. Let me do it this way. Here, and then bring it here. So again, when we're doing pie charts, right? I think that part is the important part, right? Because the relative frequency is going to give us those percentages, which is a lot easier to multiply by 360, which gives me the angle that I need to have to create these pies. Wow, that's all it is. That's all. Mhm. Okay. I didn't like this. This is not telling me certain things here. Okay. I'll have to test home. All right. Any questions on that? Let me make sure that and everything in MLM you guys can actually do in 1 and 2.1. Side by side. Talked about that. Okay. Okay. Still the same title. So in other words, it's just bar graphs, but they're just connected together. They're literally all side by side. So if we were to take what we had up here, right, instead of this, all of these bars would literally be squished together, side by side. Okay, so still, we're still talking about the same thing, right? So just as a reminder, because what I actually did was in 2.1, I explained a lot of things in 2.2 already. So that's why 2.2 is like, So remember why I said, I was talking about that we could have done this frequency chart as one age at a time, right? In other words, each category only has a class width of 1. Or we can have each category with a different class width, but if we choose a class width, we have to stay consistent with that class width. Okay. Now, let's do some thinking here. Okay, let's say that this was a preschool / stats class together. Yes. So the age range would be from 1 to 29, I think it was, right? 29, right? So there's like a span of 30, almost 30 years, right? So let's even say 0 to 30. And let's say, like this one right here, if you look at it, there's how many categories here? There's 5 classes or 5 categories, right? Again, 5 classes or 5 categories. So if I was to take those 30 ages and cut it into 5 classes, what should my class range or class width be? It ought to be 6, right? Now, most of the times, what do we think of? We think of 0 through 6, right? But are we taking too much? We are. Does that make sense, guys? Because we really have 7 in that class. Yeah. So it should be 0, 1, 2, 3, 4, 5. Right? Because if not, we're going to run out of numbers. Right? So realize that. Okay. It's not difficult, but it's something that you guys have to kind of think a little bit about. And it's funny because when I took a stats class in college around this age range, well, definitely not 16, not 17 or 18. In New York, we don't get to have a dual enrollment. There's no such thing. And that's why I've been convincing like my brother to move from Tennessee to here, because I said, your kids could graduate graduate with an associate before they graduate high school. Right. So for me, I had to take stats classes into my 20s, and they gave us a project but never explained any of this. So I had to figure out how to get those class width the right way, right? But the reason why they never explained it is because it's not that hard, but you guys have to be the ones that still have to be the one that figure it out. So there will be questions that you'll have a slew of data, right? Like this, right? You'll have a slew of data like that, and they're going to be like, okay, we want all of this data in 5 classes, in 4 classes, in 7 classes, right? And you're the one that's going to have to figure out what the class would need to be to cover everything, right? Obviously, you don't want to go, okay, I'll just do 1 through 21, right? And then the next class with it being the same, and then just go, there's only going to be one thing in that last one, just so I can cover it. Not, well, the class width is always going to be even. The frequency might not be. But don't do it where the last one is like because there's only one, let's say there's only one person that's 29. You don't want to go, okay, I'm just going to make the last one cover 29 and that's it, right? You want to make sure that there's some kind of somewhat of a distribution, okay? Now, here's the other part that you're going to notice. If I was to turn this, well, actually, never mind. As you guys look at this frequency, right? Frequency bar graph, if you guys notice, this is not really very evenly distributed. Everybody see that? Okay. So this is kind of like, and this is going to be weird because the wording doesn't make sense. This right here, oh, actually, you know what? Let's do it this way. So you might have something that is going to look something like that. Actually, let me do one more. Right? So this right here is called uniform. It's a uniform distribution. This bell-shaped, what we usually call this a normal distribution. So the age group in here is skewed right, which is weird because to me, this picture looks like it's skewed left. Does that make sense? It looks like that, but it's actually called skewed right.
So is the second one called normal distribution or bell-shaped distribution?
Well, it's just a bell-shaped curve. It's just a bell-shaped curve, but we're going to end up calling it normal distribution. And this would be skewed left. I see that it mentions something about dot plots, but I don't see any questions about dot plots. But I'm going to tell you about dot plots anyways. Drawing histogram. Because I want to make sure that you guys have all the information you guys need. Did I see that? Where did I see dot plots? There I see dot plots. Any questions on this? But you can call it bell-shaped distribution, but we're going to end up calling it normal distribution most of the time, especially when it becomes like, when we get to z-scores, we're going to be talking a lot about something like this. Right? Where we're talking about that bell-shaped curve, we're talking about normal distribution, we're talking about converting those data into z-scores and so on and so forth. Okay. All right. So let me just talk a little bit about dot plots really quick, guys. And dot plots aren't anything that is impressive at all. So remember when we did the frequency chart here? Instead of making a bar, all it is it's going to look like a bar graph, but it's just a bunch of dots. It'll be 12 dots for 16 through 18. And then 12 dots for 19 to 21. And then there will be 2 dots for 22 to 24. That's what a dot plot would be. Does that make sense? So it's not anything like engineering. No brain surgery needed. All right. I'm guessing people are packing up because it's a reminder to me that, hey, it's about that time, bud. All right. So ladies and gentlemen, if you have any questions, please feel free to message me or email me or whatever. All right. So please have a wonderful, blessed day. Please have a wonderful weekend. Please be safe. Love you guys. I'll see you guys next Monday. Later. Bye.